When a comet shifts its path right when we're least able to watch, that's not luck. That's timing. And if that shift lines up with a trajectory change that just doesn't add up, at least not if you believe it's just ice turning into gas and pushing things around, astronomers stop calling it a coincidence. They start calling it weird. That's exactly what happened with 3IATLAS, the interstellar object that cruised into our solar system in 2024. It changed direction. And not in the usual messy way comets do, all wild jets and random tumbles. No, this thing moved like it was following instructions. NASA's got the data. JPL ran the numbers over and over. The official story. Nothing to see here, just another comet acting like a comet. But if you look closer, at the timing, the speed up, the place it turned, and the route it's taking now, that explanation stops feeling right. Physics can explain a lot, but not a move this precise. Not a course change that happens right when our telescopes are blinded by the sun. And definitely not an interstellar rock flying like it's got somewhere to be. But the real story doesn't start with the discovery. It starts with what happened after. They first spotted 3IATLAS on July 1, 2025 with the Atlas survey in Chile. At first, it was just a faint blur drifting through the asteroid belt. Nothing special. Another number in the catalog. But within 2 days, astronomers realized they had something wild. The path was hyperbolic, meaning this thing wasn't from around here and wasn't sticking around either. Interstellar. Only the third confirmed one after in 2017 and in 2019. That alone was enough to send observatories worldwide scrambling. Locked on, squeezing every bit of detail from its aging sensors. The James Space Telescope, the new kid on the block, pointed its infrared eyes at it. Ground-based telescopes from Hawaii to Texas joined in. Even spacecraft orbiting Mars and missions like SOHO, built to watch the sun, started gathering whatever they could. This wasn't just curiosity, it was an all-hands-on-deck moment. Interstellar objects are rare, and when one shows up, you throw everything you've got at it before it vanishes for good. Now here, where the timing gets really odd. 3IATLAS popped up in 2025. Right now, it's on track to cross Jupiter's Hill radius in 2026. That's not much time in cosmic terms. These objects are so rare that we've only confirmed 3, and the first was less than 10 years ago. The odds of inventing the tech to spot them and then immediately running into one with behavior like this, practically zero. Unless, maybe, the timing isn't random. Maybe 3IATLAS showed up now because now is when we're able to spot it. It's a weird, unsettling idea, but some scientists are quietly wondering about it. If you wanted to make contact with a civilization on the rise, you wouldn't show up before they could notice you. You'd wait until their telescopes were good enough to see you, but maybe not good enough to figure everything out or do anything about it. That's us right now. 3IATLAS hit perihelion, its closest swing by the sun, on October 30, 2025. It passed about 1.4 astronomical units from the sun, just inside Mars's orbit. For scale, Earth sits at 1 AU, so this thing got close, but not dangerously so. Comets usually get their most dramatic right around perihelion, when sunlight boils off their ices and gives them those wild tails. Every telescope that could see it was watching. Spectrographs were running non-stop to figure out what gases it was throwing off. Photometry tracked its brightness for signs of spinning or breaking up. Polarimetry measured how sunlight bounced off the dust and ice to learn what it was made of. It was a full-court press, the kind of worldwide, coordinated effort you only see when something truly unique wanders through our cosmic backyard. And then the sun messed everything up. Solar conjunction, when Earth, the sun, and your target line up with the sun smack in the middle, just happens. It's basic orbital mechanics, no way around it. The sun's glare drowns out telescopes, and radio signals get lost in all that solar noise. For a stretch that can last days or even weeks, depending on where everything is in space, astronomers basically go blind. That's what happened to 3IATLAS. Its blackout window hit from late October into early November. For about 40 to 60 hours, nobody could track it with any real accuracy. It slipped behind the sun from our point of view, and when it came back, things were off. The numbers didn't line up. The orbit changed. Not enough to make headlines, but enough that every scientist paying attention saw it right away. Turns out the comet had gone through what's called a non-gravitational acceleration event, a speed change that gravity alone can't explain. Here, where the official explanations start to feel shaky, non-gravitational kicks aren't rare in comet science. Actually, they're pretty standard. Comets are weird, messy mixes of ice and rock. When they swing close to the sun, the ice heats up and goes straight to gas. This outgassing throws jets of vapor into space, nudging the comet's path. It's been seen over and over with dozens of comets. So when 3IATLAS changed speed after swinging by the sun, everyone just chalked it up to outgassing. Sun heats up the ice, jets fire off, the comet drifts onto a slightly new path. Textbook stuff. Nothing weird, except if you dig into the details, things don't add up. The acceleration was small but clear, right in the range you'd expect from some outgassing. But the direction was weirdly precise. The velocity change pointed suspiciously exactly in the direction needed to tweak the comet's path. Not close, not pretty much there. Dead on. Anyone who knows orbital mechanics felt their stomach drop. Here, why that's a big deal. Outgassing is messy. Comets aren't smooth, round balls, they're lumpy, spinning, unpredictable. When sunlight hits one side, jets shoot off in all directions, but as the comet turns and the ice melts at different rates, those jets flicker on and off like faulty sprinklers. 1 minute you get a jet firing north. Next, the comet spins and there's nothing. Then suddenly a new jet fires east. The whole thing is chaotic. The comet wobbles, spins, drifts. You can't predict where it'll go next without constantly recalculating, because the forces are random and always changing. But 3IATLAS didn't follow that script. The acceleration happened while it was behind the sun, right when astronomers couldn't watch. When it popped back into view, its speed had changed in a way that steered it closer to Jupiter. Not just to Jupiter, but straight toward a spot called the Hill Sphere. That's the region where Jupiter's gravity takes over from the sun's, a kind of cosmic parking lot where things can just hang out, stable and unbothered. That's not some random place to end up. The Hill Sphere is a gravitational sweet spot, and now 3IATLAS was aimed perfectly to slip right into it. Sure, random outgassing could theoretically nudge a comet in any direction, but getting exactly the right push at exactly the right time to send it right where it needed to go. The odds aren't zero, but they're close enough to make scientists shift in their seats. If this was just some random interstellar comet blundering into Jupiter's Hill radius, we'd see a wild, lopsided orbit, something unstable that wouldn't last long. It'd whip around Jupiter a few times, tracing a stretched-out, unpredictable path. Then, it'd either slingshot back into the void or smash into Jupiter or one of its moons. That's the usual story for objects drifting aimlessly, letting gravity do all the work. But here's the weird part. A handful of orbital analysts, some working outside the usual channels, have noticed something off about 3IATLAS. Its approach doesn't look random at all. Instead, it looks calculated, like someone planned every detail to slip it into a very particular orbit. The speed matches up too closely. The entry angle is almost perfect. It's like watching someone nail a high-difficulty move on the first try, and you can't help but wonder if they practiced. Now this is where mainstream science draws the line. There's no solid evidence, no odd signals, no weird materials, nothing that screams artificial. 3IATLAS looks for all the world like a regular comet. And really, it makes sense for astronomers to be skeptical. Science isn't supposed to jump to the wildest explanation when a boring one still fits. The bar for proof is high, and it should be. But here, the debate bubbling up in some corners of the astronomy world. Maybe we're being too rigid about what counts as evidence. We're so focused on finding radio transmissions, shiny metal bits, or obvious engines. But what if the only clue is the way this thing moves? What if the precision itself, the exact timing of its speed up, the delicate tweaks during conjunction, what if that's the signature? Maybe we're looking at something built to blend in, to mimic nature so closely that it slips right past our radar, all while doing exactly what it was supposed to do. Let's talk about the solar conjunction, because this is where things get almost too neat. Solar conjunction is no surprise. Astronomers know exactly when a comet will pass behind the sun from Earth's point of view. For 3IATLAS, everyone had already marked the date, and right during that 40 to 60 hour period, when the sun blocks our view and precise tracking is impossible, the object sped up. Not before, when telescopes could have caught it. Not after, when we could double-check the data. Right in the blackout window. The official story. It lines up perfectly with what you'd expect from a natural comet. At perihelion, when it's closest to the sun, comets get the most solar heating and become most active. That's just how the orbits work. Perihelion and conjunction happen at the same time, so the sun gets in the way right when the comet is at its wildest. Nothing suspicious about it, just the laws of physics. But let's flip it around. If you were building a probe and wanted to sneak in a course change without anyone noticing, you pick this exact moment. You use perihelion for the energy and conjunction for the cover. Earth's telescopes are blind. If your propulsion happened to look just like cometary ice turning to vapor, even better. The sun's heat gives you both power and camouflage. It's the perfect time for a burn, whether you're a natural object or something else. And honestly, if you asked an orbital mechanics expert how to slip through a busy solar system without getting caught, this is exactly what they'd suggest. Use perihelion for maximum juice, conjunction for maximum stealth, make your burn look like natural outgassing, and time it so no one can prove a thing. Let's dig into what the Hill radius really means, because it's at the heart of why this trajectory stuff matters so much. Picture any big object out in space. It carves out a region around itself where its gravity calls the shots. For a planet circling a star, that zone's called the Hill sphere, or Hill radius. It's like a fence around the planet, marking off where the planet's gravity can keep moons or other things from being yanked away by the star. Take Jupiter, for example. Its Hill radius stretches out about 53 million kilometers from the center. That's huge. We're talking a region about as wide as Mercury's whole orbit around the sun. Inside that invisible fence, Jupiter's gravity wins out over the sun's. That's why its moons stick around, and why spacecraft aim for this area if they want to orbit Jupiter without wasting fuel fighting the sun's pull. Now for the weird part. The predicted intercept point for 3IATLAS, the spot where it's supposed to cross into Jupiter's Hill sphere, isn't just a rough estimate. It's not even close to being in the ballpark. The latest calculations say this thing will hit the Hill sphere at exactly 53.445 million kilometers from Jupiter's center, give or take 60,000 kilometers. 60,000 sounds big, sure, but not on this scale. That's not just close, that's dead on. It's like threading a needle from half a solar system away. Try imagining this. You throw a dart from New York, hopping to hit a bullseye in Los Angeles. The dartboard's moving, you're moving, there's no air, and you actually threw the dart 7 years ago, not even knowing where the board would end up. That's the level of accuracy we're looking at here. Comets just don't behave like this. They can't. Their paths get kicked around by all sorts of random forces, little nudges, gravitational tugs, things you simply can't predict years ahead of time. Let's clear up the difference between a close approach and real targeting. Tons of stuff swings near planets all the time. The solar system's full of wandering rocks and ice balls, and sometimes they breeze past Jupiter or Saturn by pure chance. But there's a world of difference between just passing nearby and hitting a specific boundary, like the Hill radius, with only a tiny margin for error, especially when you're starting way out in interstellar space. Getting that close by luck, sure, it can happen, but hitting that target on purpose, that takes either impossible luck or someone steering the ship. And 3IATLAS isn't just grazing the boundary, it's nailing it, with the kind of precision NASA mission planners sweat over for years when plotting real spacecraft routes. Some scientists push back, saying maybe this accuracy isn't real. Maybe it only looks that way because of the way we're measuring things. After all, orbital calculations depend on observations, and there's always a bit of fuzziness. Track something across billions of kilometers, and even tiny errors in position or speed get blown way out of proportion. Maybe the data's not as tight as we think. Maybe there's a bigger margin of error and we're just seeing patterns in the noise. That's a fair point, and it's exactly the kind of doubt science needs. But here's the catch. We've got a mountain of observations on 3IATLAS. Different telescopes, different wavelengths, months of tracking. The more data we get, the better the numbers look. The uncertainty keeps shrinking, not growing. The trajectory's getting sharper, not fuzzier. If this was just measurement noise, you'd expect the opposite. The more you look, the blurrier things should get. But no, every new observation makes the intercept look even more intentional, less random. So what happens after 3IATLAS hits Jupiter's Hill radius? That's where things get interesting, and honestly a bit speculative. But this isn't just wild guessing. Orbital mechanics gives us some solid ground to stand on. When something crosses into a planet's Hill sphere, a few things can play out. Sometimes the object just passes through, barely nudged by the planet's gravity. Other times it gets snagged for a bit, loops around the planet a few times, then either escapes or crashes. And once in a while, the planet catches it for good, turning it into a new moon. Which path it takes depends on how fast it's moving, the angle it comes in at, and the whole setup of the encounter. For 3IATLAS, its path means it'll slip into the Hill radius at a speed that's on the slow side compared to what it would need to break free from Jupiter. So, there's a real shot at capture. Not a guarantee, but definitely possible. If both the speed and angle line up just right, Jupiter could pull it in and keep it. Looking ahead, astronomers have a few scenarios in mind. 1. 3IATLAS gets caught in a stretched-out orbit, swooping close to Jupiter, then swinging way out before coming back in. If that's how it goes, we'll get several chances to observe it up close and from a distance. Every pass means new data, and comparing those snapshots could reveal patterns we'd miss with just a single look. There's also the chance that the object won't hold together. Jupiter's gravity is no joke. If 3IATLAS is fragile or loosely packed, the stress could tear it apart. And honestly, that would be a goldmine for science. We get to see what it's made of inside, not just the surface. But maybe none of that happens. Maybe 3IATLAS slips in, makes a little course tweak, and settles into a stable orbit, just hanging out inside Jupiter's gravitational reach for good. That would be huge. Usually when planets snag something, it's temporary and messy. A permanent, stable capture from deep space. That would be rare, almost like someone parked it there on purpose. If that's what we see, you can bet the debate over whether this thing is natural or artificial is going to blow up. Now, if this was just some random interstellar comet blundering into Jupiter's neighborhood, you'd expect a wild, stretched-out, unstable orbit. It would loop around a few times, then either get flung back into space or crash into Jupiter or one of its moons. That's just how gravity tends to work with objects that aren't steering themselves. But here's the thing. Some orbital analysts, folks working on their own, not always through official channels, have noticed something weird. The way 3IATLAS is coming in doesn't look random. The speed matches up too neatly. The angle is right on the money. It really does look like someone plotted the perfect course to slip into orbit around Jupiter, then pulled it off with almost suspicious precision. This is where mainstream science draws the line. There's just no solid evidence, no weird signals, no strange structures, no propulsion trails, nothing that hints 3IATLAS is anything but a regular comet. The idea that it's making some sort of controlled maneuver. Most astronomers see that as a wild claim without the facts to back it up. And honestly, they have a point. Science doesn't leap to wild theories when simple explanations still work. The bar for proof is high, and it should be. But there's another side to this, one that keeps popping up in late-night conversations among astronomers. Maybe we're thinking about evidence too narrowly. We keep looking for radio chatter, shiny metal, or some obvious sign of technology. But what if the real clue is in the way it moves? What if the orbit's precision, the timing of that acceleration, the way it sharpens up during conjunction? What if that's the signature? What if we're watching something designed to look natural, flying so close to the line that it gets lost in the noise but still does exactly what it's supposed to do? Let's dig into that solar conjunction, because the timing there almost feels too perfect. Solar conjunction isn't a surprise. Astronomers know exactly when something will pass behind the sun from Earth's point of view. With 3IATLAS, everyone had that window circled on their calendars long before it happened. And right in the middle of that 40-60-hour blackout, when nobody could track it closely, the object picked up speed. Not before, when telescopes could have caught everything. Not after, when every movement could be checked and double-checked. No, it happened right in the blind spot. The official story says this all fits with a natural comet. Perihelion is when comets get most active because they're closest to the sun, and that lines up with conjunction just because of how orbits work. The sun blocks the view because the comet is at its closest. Nothing odd, just physics. But let's say you wanted to sneak in a course correction with a probe. You pick perihelion for the extra solar power. You pick conjunction because nobody on Earth can watch you. If your engines vented something that looked like regular comet ice turning to gas, that's perfect camouflage. The sun gives you both the power and the cover. Honestly, it'd be the perfect time for a burn, whether you're a comet or not. Ask any orbital mechanics engineer to come up with the most efficient, stealthy way to change course in a busy star system, and odds are, this is exactly what they'd suggest. Use perihelion for power, conjunction for cover, make your maneuver look like natural outgassing, and time it so nobody can ever be sure what happened. Most astronomers studying 3IATLAS are convinced it's a comet. They don't see any need to reach for the extraordinary. The weird acceleration matches what you'd expect from outgassing, even if the direction is unusually convenient. The course correction fits within what's possible for natural objects, even if it's right at the edge. The timing, well, it's just a coincidence, though a weirdly helpful one. These are reasonable takes from people who know comets and orbits inside and out. But there's a smaller group, including some respected folks at places like Harvard and UC, who aren't so convinced. They're not saying this is definitely artificial. They're just pointing out that things don't quite add up, that the data is odd enough to dig deeper, and maybe it's too soon to rule out the idea that someone, guided the trajectory. Professor Avi Loeb at Harvard stands out as one of the loudest voices urging people to take these anomalies seriously. He's the guy who made headlines by arguing Oumuamua, that weird interstellar object we spotted a while back, could actually be artificial. With 3IATLAS, though, Loeb's taking a more careful approach. Still, he keeps pointing out, both in his papers and interviews, that the object's precise path and the timing of its sudden speed-up deserve real attention. He's not claiming it's a spacecraft. He just wants everyone to keep an open mind and look at every explanation that matches the evidence, even if some of those options make people uncomfortable. In a field where just floating unusual ideas can hurt your career, that's a gutsy move, and he's not the only one. Other researchers, some of them working solo or outside the usual academic circles, have run their own numbers and come away thinking the odds of normal comet outgassing causing what we're seeing seem pretty slim. Not impossible, but low enough that it's worth considering other possibilities. Then there's all the stuff we're not seeing. If 3IATLAS is just a comet that suddenly started spewing gas hard enough to change its path, we should notice a few things. There should be jets, actual streams of gas and dust blasting out from the surface. The brightness should flicker as different active spots spin in and out of sunlight. The spectrum should shift as new ices get exposed and vaporize. We should see dust drifting away, carried by the gas. Sure, some of that's there. The coma exists, but it's faint and even. There's dust, but not much. The spectral data show water and carbon dioxide, so it looks like a comet. But honestly, the whole thing seems oddly quiet for something that just pulled off a measurable speed change. This mismatch leads to what some scientists call the energy budget problem. If 3IATLAS is on the small side, say 400 or 500 meters across, then to get the kind of acceleration we saw, it would need to blast out a huge amount of gas from every bit of its surface. That takes a ton of energy, way more than you'd expect from a sun-warmed chunk of ice and rock. People have tried to explain this away. Maybe its surface is unusually dark, soaking up more sunlight. Maybe it had built-up pockets of gas that let loose all at once. Maybe it just spun the right way to expose a fresh patch of ice. These are all possible, but they're really just tweaks to make the numbers work after the fact. And once you start stacking those fixes, you have to wonder if you're actually explaining what's going on or just patching holes. If the object's bigger, more like 5 or 6 kilometers across, the energy problem's not as bad. There's more surface, so each patch doesn't have to work as hard. But then you hit another snag. A bigger object has more mass, so it takes even more gas to get the same push. That circles you right back to the activity issue. No matter how you fiddle with the numbers, something always feels off. Either it's too active for its size or too big for the speed up, or the outgassing seems weirdly focused, not random. You can make any one detail fit if you stretch things far enough, but getting the whole story to line up, that's a lot tougher. Let's get into what 3IATLAS actually looks like, because honestly, appearances still matter, even when everyone's obsessed with data and computer models. Most of what we know comes from big observatories, the kind run by NASA, ESA, or major universities. Through those telescopes, 3IATLAS shows up as a fuzzy, hazy blob, bright in the middle, wrapped in a cloud of gas and dust. There's a faint tail, but not the dramatic, sweeping one you'd expect from a super-active comet. All in all, it acts like a comet that's letting off gas, nothing that screams weird. But then you get the amateur images. These aren't grainy snapshots. Some of these astrophotographers have serious skill, even if they're using equipment you can actually buy. And sometimes their pictures look different. Instead of a vague smudge, they show a tighter, more structured object, a clear core with the material around it looking almost organized. The wildest example came from someone who caught 3IATLAS with a crisp, almost tube-like bright area, surrounded by this blue halo that didn't really look like just sunlight bouncing off dust. Once the photos went online, the debate started right away. Professional astronomers pointed out that heavy image processing, stacking photos, cranking up the contrast, applying fancy algorithms, can create all kinds of fake details. Amateurs pushed back, saying they used the same techniques that work for other comets and galaxies, and that multiple people working separately saw the same thing. Nobody's settled it yet. The official line is that the structure is just an artifact, a trick of the processing. But when different folks in different places keep seeing the same pattern, you have to wonder if something real is there, even if the software makes it look more intense. Meanwhile, there's a growing pile of amateur observations nobody's really sorted through yet. Hundreds of people all over the world have aimed their backyard scopes at 3IATLAS in the last few months. They're using all kinds of setups, at all hours, from all sorts of locations. That mix actually makes the data more useful. If this comet is doing anything weird or short-lived, amateurs have a shot at catching it when the big observatories aren't watching. Some have reported quick flashes or changes in brightness that don't show up in the official records. Sure, a lot of those probably are just glitches or mistakes, but sometimes it feels like we're too fast to write off anything that doesn't fit the usual story. What if, just once, one of these oddball reports is the real thing? And then there's the color. Most comets are pretty plain in true color, white or a bit yellow, since they're just reflecting sunlight off ice and dust. Ones with lots of carbon dioxide get a reddish tinge from organic stuff in the dust. But a few people have picked up a faint blue glow from 3IATLAS, especially in the bluer part of the spectrum and near ultraviolet. Blue's not a common comet color. Maybe it's tiny dust grains scattering those short wavelengths. Maybe it's some molecule in the coma lighting up. Or maybe it's something else entirely. The point is, even the way 3IATLAS looks is raising questions nobody can really answer yet. Sometimes it fits the comet mold, but sometimes it just feels a bit too clean, too neat, too strange. It's tough to make sense of 3IATLAS because, honestly, we just don't have much to compare it to. Oumuamua was the first interstellar comet we caught, and it was weird, long, skinny, and moving in ways that didn't make sense. People are still arguing about it. Then came 2I/Borisov, which looked like a regular comet. Outgassing, normal makeup, nothing too wild. Now there's 3IATLAS, and it's not quite either. It acts like a comet, but its path is oddly precise. It's outgassing, but the jets are either hidden or strangely balanced. It sped up near the sun, but the way it did that feels almost too perfect. Bottom line, we've got 3 interstellar objects and none of them really match. With a sample size this small, who knows what's normal? The stats are a nightmare. Think about it. How many interstellar objects slip through the solar system without us ever seeing them? Some are probably too tiny, too dark, too fast, or flying paths that never bring them close enough for our telescopes to catch. We're only spotting the ones that get close, shine enough light, or happen to cross our line of sight. For every one we find, there might be dozens or hundreds we miss. If that's true, then maybe weird ones like 3IATLAS aren't so rare after all. Maybe precise paths happen more often in a bigger crowd. Or, and this is the kind of thing that keeps astronomers up at night, maybe the ones we do notice aren't random. Maybe they're the ones that want to be seen. The thought that some of these interstellar objects might be artificial is exactly new. Scientists have kicked this idea around for decades, ever since we realized stars toss stuff out into the galaxy. Back in 1960, Freeman Dyson wrote about the idea of interstellar probes. Basically, smart little spacecraft sent out by advanced civilizations to check out other stars. In the 80s, Carl Sagan and others ran with the concept of self-replicating probes, spreading across the galaxy over millions of years. Recently, folks like Avi Loeb have started talking about all this again, now that we're actually spotting these objects. The reasoning is pretty simple. If there are other smart civilizations out there and they want to explore, it makes way more sense to send probes than to send people. Probes are cheap, tough, and can just keep going for centuries. Plus, if you're building probes, you want them to be efficient, hard to spot, and able to last a long time. There's this idea in astrobiology and SETI called the zoo hypothesis. It goes like this. Maybe advanced civilizations already know about us but keep their distance, watching quietly, kind of like zookeepers or park rangers. It's one way people try to answer the Fermi paradox. Why, with such a huge and old galaxy, haven't we seen any signs of aliens yet? The zoo hypothesis always sounded pretty far-fetched, but 3IATLAS gives it a little more substance. If you wanted to watch a civilization from afar without messing with it, you'd send out probes. You'd put them in stable orbits so they could hang around for ages, and you'd make them just ambiguous enough, natural enough to avoid setting off alarms, but strange enough that, once the locals got smart, they'd start to wonder. Try looking at this through the eyes of a civilization that's way ahead of us. You want to know if anyone else is out there, but you really don't want to mess up their progress or tip them off too early. So you send out probes, machines built to last millions of years if they have to. They pick a promising star, settle in, and just wait. They watch for signs of intelligence, maybe something like the ability to spot and track objects drifting between the stars. When the moment's right, the probes don't roll out the red carpet. No dramatic light shows or blaring messages. Instead, they act a little odd, just enough to get noticed to make the locals start asking questions about their place in the universe. It's a way to say we're here without ever saying it. And if nobody picks up on the hints, no big deal. The probes keep quiet and life on the planet carries on, none the wiser. One idea that keeps popping up in these circles is the solar sail or light sail. It's simple in theory. You make a huge, super thin mirror and let starlight push it along. No engines, no fuel, just photons doing the work, slowly nudging the craft up to a good chunk of light speed if you're patient. It's not just science fiction either. People are working on these things right now, both in research labs and private companies, mostly for missions inside our own solar system. The physics are solid, and we could actually build one with tech that's available or just around the corner. Here, where it gets interesting. If a light sail zipped through a star system, it would feel a kick from the sun's light, especially at its closest approach. From far away, that acceleration would look a lot like a comet venting gas. Both give a steady push, strongest near the sun. Both tweak the object's path in subtle ways. If you can't actually see the thing up close, which we can't with something tiny and far away like 3IATLAS, it's tough to tell the difference. Just to set the record straight, there's no proof that 3IATLAS is a light sail. We haven't picked up any metallic glints, no weird reflections, nothing that screams giant shiny sheet. The stuff we have points to regular comet material, water, ice, CO2, dust, the usual suspects. But then you look at how it's moving, the way it hit the Hill's sphere just so, the timing of its speed changes. That's trickier to chalk up to ordinary ice and sunlight. So here's the weird part. The chemistry says comet, but the way it moves says maybe not just a comet. We're stuck trying to make sense of two stories that don't quite match up. There's another theory that doesn't get much airtime publicly, but scientists kick it around in private. What if 3IATLAS isn't just one thing? What if it's a bigger object carrying smaller pieces inside, set to release them at the right moment? In interstellar mission planning, this makes a lot of sense. You send one sturdy carrier to cross the gulf between stars, keeping its cargo safe from radiation and space dust. When it finally arrives, it drops off smaller probes that fan out. Some head for planets that could support life. Others park themselves at stable points in space. Maybe a few hang around the big gas giants. The main body could keep going or stick around to relay messages. You get a lot of bang for your buck with this approach. If that's what 3IATLAS really is, what should we expect to see? Honestly, probably nothing obvious at first. The smaller pieces could slip away quietly, especially if they're designed to avoid attention. No flares, no radio beacons, nothing flashy. Maybe the main object breaks up a little. Comets do that all the time, so nobody would think twice. Maybe we'd notice it dim or spin differently as it sheds mass, but unless we're actively looking for signs of a controlled release, we'd likely miss it. Even if something odd did stand out, the safe bet would be natural breakup, thermal stress, a weak spot giving way. That's just what comets do. It's almost their signature move. Jupiter's Hill radius is honestly a perfect spot if you want to scatter a bunch of observation probes around the solar system. The place is stable. Things parked out there don't need constant nudging to stay put. It's also tucked far enough from the sun that radiation isn't as brutal as it is closer in, but still close enough to Earth that you can get a radio signal out there in less than an hour. That makes it ideal for listening in on all the stray signals our planet throws off. Plus, from that vantage point, probes get a clear view of the inner planets, the real action, where rocky worlds and complicated chemistry set the stage for life. If you were designing a surveillance network and wanted to keep an eye on a star system for the long haul, you put Jupiter's Hill radius right near the top of your list. Jupiter's system itself is weird, and that's not just idle curiosity. It's got a swarm of moons, dozens, and many of them move in odd, lopsided paths that say they weren't born there, but got snagged as they drifted by. Some of these moons are tiny, only a few kilometers wide, tough to spot, and way out near the edge of the Hill radius. We barely know anything about them. We don't really know what they're made of or exactly where they came from. Most of them only popped up in our surveys over the last few decades, once our telescopes got good enough to find such faint stuff. Sure, a lot of them are probably just random asteroids that got caught by Jupiter's gravity. Maybe all of them are. But the thing is, that region is already filled with small, dark objects we don't understand. If you slipped a few more into the mix, who would notice unless they were looking for something specific? The more you dig into 3IATLAS, the more it feels like some kind of test. Not a hostile one, just something that sits right at the edge of what we can explain. It's got enough comet-like features to pass as natural, but just enough weirdness to keep us guessing. It follows predictable patterns, so we can model its path, but those models stretch our assumptions more than we're comfortable with. It's as if someone set out to see just how close they could get to being discovered without actually tipping us off. Or maybe that's just us overthinking things. We're pattern-hungry creatures, wired to see intention everywhere, even in noise. When the data is murky and the signals are fuzzy, it's all too easy to build stories out of nothing. Is that what's going on with 3IATLAS? We have no proof, no hard evidence, just a set of observations that don't quite fit what we expect from a natural comet and a pattern that nags at us. That's the trouble with trying to spot alien technology. We don't really know what to look for. We expect to see ourselves, radio bursts, metal machines, chemical rockets, but a civilization millions of years ahead of us. Their technology would be so advanced, we probably wouldn't even recognize it. To us, it might just look like nature doing its thing because they know how to blend right in, propelling with ice, feeding off solar energy, riding gravity like pros. We see a comet. Maybe from their side it's a masterpiece of engineering. And then, of course, you have to wonder what it wants, if it wants anything at all. Say 3IATLAS is a probe. Maybe it's here to watch, to gather data about the solar system, about Earth, maybe just listening to all the radio chatter we send skyward. But for what? Science. Mapping resources, gauging threats. We don't have a clue. The probe, if that's what it is, isn't talking. And if we try to talk to it, we wouldn't even know where to start. Should we beam out a radio message, chase it down with a spacecraft, or just keep watching, hoping it does something that gives the game away? Every first contact scenario we dream up assumes the other side wants to talk. But what if the probe is just a silent observer, a camera in the woods, recording everything but never joining the conversation? There's this big problem with our search. We don't even know what we're missing. All our observation methods are built on the things we already understand. So we aim our antennas at the sky, hopping for radio signals because that's what we use to talk. We scan for shiny metal because our own spacecraft are made of metal. We look for the roar of rocket engines because that's what we're used to. But what happens if a truly advanced civilization shows up with tech that's nothing like ours? What if their probes run on stuff we've never even imagined? Maybe their way of communicating doesn't even show up on our instruments. We just don't have the right kind of ears. Science history is full of moments like this, where something was hiding in plain sight and we just didn't know how to look for it. X-rays, they were there all along. Radio waves, same story. It took us building the right tools before we even realized there was something to find. So who says there aren't whole categories of phenomena swirling around 3IATLAS that we just can't see yet, simply because we don't know to look? A few scientists are saying we should switch gears. Instead of hunting for what's familiar, maybe we need to keep our eyes open for anything weird or out of place. Odd brightness changes, strange spectral signatures, patterns that look too regular to be random. Sure, it's messier science. You're not setting out to prove anything specific. You're just hopping to spot something that doesn't fit. But with 3IATLAS, where everything is already a bit off, chasing more anomalies might actually be our best move. We might not find what we expect, but we could stumble onto something we never even thought to search for. That's how some of the best discoveries happen. The truth is, what we really need right now is more data, and we're running out of time. 3IATLAS is drifting away from the sun, getting dimmer every day. By early 2026, only the biggest telescopes will have a shot at seeing it clearly. That window is closing fast. If we don't grab the right measurements while it's still bright enough, we'll lose our chance to really understand it. That's the tough part about astronomy. The universe doesn't care about our schedules or our unfinished instruments. Things show up, pass by, and vanish again. If we're not prepared, if we're not watching the right way at the right moment, we miss out. And once it's gone, that's it. Looking at its path, 3IATLAS will hit the Hill radius boundary sometime around mid to late 2026, so we've got about 18 to 20 months. That's our countdown. And honestly, it could be the biggest astronomical event of our era. Every major telescope, both on the ground and in space, will be focused on this thing. Webb will keep a close eye on its heat signature, scanning for any odd warmth or strange surface features. Hubble's still got game, and it'll be snapping high-res shots to catch any changes or breakups. Ground-based observatories, from Hawaii's Keck telescopes to Chile's Very Large Telescope, are all teaming up to collect the most detailed data set ever on an interstellar visitor. Research teams everywhere are racing against the clock, squeezing out every bit of information before 3IATLAS fades away. Imaging teams want to resolve the nucleus, pin down its size and shape. Spectroscopists are watching how the comet's composition changes, hopping to catch new layers being exposed as it vents gas. Polarimetry folks are tracking how light bounces off dust, trying to figure out what the surface is really like. And orbital analysts are double-checking the trajectory, watching out for any weird movements that might point to something unexpected. Every hour with a telescope counts. Every new data point gets us one step closer to the truth. Here, why this timeline matters so much. If 3IATLAS is just a regular comet, just rock and ice obeying physics, then its encounter with Jupiter shouldn't be a big deal. It'll drift into Jupiter's Hill sphere, get tugged around by gravity, and either swing past or maybe get caught in orbit. What happens next comes down to its speed and the angle it's coming in, stuff we can already calculate pretty well. The predictions are out there. If what we see matches those predictions, that's a solid point for it's a natural comet theory. But if it does something weird, say, changes course or speeds up or slows down in ways Jupiter's gravity can't explain, then it gets a lot harder to rule out stranger ideas. Some teams are already gearing up for that possibility. They're building observation protocols that look for any sign the object is actually steering itself during approach, tiny velocity changes, even ones too small for our usual instruments, but still detectable if you know exactly where to look. They're watching how fast it spins, because a sudden boost would probably mess with its rotation. There's spectroscopic monitoring in the works too, to catch any odd emissions that might mean thrusters firing or some kind of energy release. And radio telescopes are in on it, listening close for any signal, just in case something tries to broadcast as it gets near Jupiter. No interstellar object has ever gotten this much attention, and honestly, it's just going to get more intense as the flyby gets closer. Artificial intelligence is playing a big role here, too. Machine learning systems are sifting through mountains of telescope data, spotting patterns or oddities a human might miss. These algorithms can scan thousands of images in seconds and flag anything out of place. They're especially good at catching subtle, slow changes, shifts in brightness or position that are invisible in a single photo, but pop out when you stack hundreds together. Some teams are even sending these AI tools back through old sky surveys, searching for any sign 3IATLAS was here before anyone noticed. If it turns out this object has passed through the solar system before, that's a big deal. It would mean interstellar visitors aren't as rare as we thought. We just didn't have the right tools to spot them until now. There's another, more controversial search happening outside the official networks. Independent researchers and some private groups with deep pockets are trying to pick up radio signals from 3IATLAS. SETI's pointed their antennas at it, listening for anything that sounds like technology. So far, radio silence. That doesn't prove anything, though. A probe that wants to stay hidden or that's just powered down wouldn't be broadcasting anyway. But if it does send out a signal, this is our window to catch it. Once it heads out past the inner solar system, the distance and faintness will make it almost impossible to detect. But let's say we do find real evidence that this thing isn't just a rock. Now what? There's no rule book for how humanity should respond to an interstellar probe. Do we try to talk to it? Send something to intercept? Just watch and see what happens. These aren't just fun hypotheticals. If 3IATLAS turns out to be the real deal, an object under intelligent control, that's a seismic shift. Suddenly we're face to face with technology that isn't ours. Governments, scientists, the public, everyone's going to have to figure out how to react. And honestly, history doesn't inspire much confidence. Even first contact between human cultures has rarely gone smoothly. Nobody's really figured out the legal or political side of all this. Who actually has the right to decide what happens with an interstellar object passing through our solar system? The Outer Space Treaty from 1967 says no country can claim outer space as their own. But honestly, that was written with human stuff in mind. Does it even cover things built by someone else, from somewhere else? If we found clear proof that 3IATLAS was artificial, would any international rules kick in? The United Nations has some guidelines for what to do if we pick up signs of extraterrestrial intelligence, but they're vague and untested. Plus, those rules expect radio signals, not chunks of alien hardware. Finding a probe, an actual physical artifact, would be a whole new situation. Our laws and diplomatic playbooks just aren't set up for that. Then there's the issue of what we tell everyone else. Right now, 3IATLAS is just a weird comet. Hardly anyone outside astronomy circles even notices it. But if solid evidence came out that it's artificial, things would go wild overnight. The media would pounce. Social media would spiral out of control with every wild theory imaginable. Governments would have to respond, explain things, take action, do something. Scientists would get squeezed in the middle, trying to keep things factual and careful while everyone demands answers they can't really give yet. The risk of messing this up is huge. If you say too much too early, people panic or laugh it off. Say too little, and suddenly everyone thinks there's a cover-up. There's no easy way to balance honesty with caution here, and there's definitely no set of instructions for how to get it right. Some researchers say we should be planning for this now, making protocols and figuring out how we talk about it before it actually happens. NASA has started talking internally about what to do if they confirm something really strange. There's the SETI Post-Detection Task Group, a loose group of scientists and policy folks who have been thinking about these questions for years, though mostly about radio signals, not objects. But let's be honest, most organizations aren't ready. Most governments haven't thought seriously about what alien technology in our solar system would actually mean. And the public, we've got no real way to process that kind of news. We're used to sci-fi, giant invasions, or wise aliens sharing cosmic secrets. The reality, a silent probe tweaking its path near the sun just doesn't fit those stories. It's weirdly quiet, hard to read, and honestly, a bit disappointing if you're waiting for fireworks. But maybe that's the most likely way first contact actually plays out. Not spaceships landing, not some message beamed from the stars, just something that acts a little off, leaves us with questions we can't answer, and makes us wonder if we're really alone. It's more of a riddle than an event, and maybe that's the point. Maybe any civilization smart enough to send probes this far knows that slow, gradual hints are safer than a sudden hello. Maybe they've done this before and figured out that a bit of mystery is better than total clarity, that letting us reach our own conclusions is less disruptive than spelling everything out. There's a real psychological angle here that's easy to overlook. Imagine the scientific community, and honestly, everyone else too, spending a year and a half hyping up this encounter, waiting for something unforgettable, and then nothing happens. 3IATLAS just swings past, follows its predicted path through the Hill's sphere, and slips back into interstellar space like any other comet. In a way, that's comforting. The universe sticks to the script. Physics works the way we think it does. No wild surprises. We get to keep our familiar ideas about comets and cosmic visitors, and space goes back to being mostly empty and indifferent. But let's be real, it's also kind of a letdown. For a brief moment, we had a shot at something truly strange. We had weird data, nagging questions, a sense that maybe, just maybe, we were witnessing first contact in slow motion. If it all turns out to be natural, we lose that spark. Suddenly, we're back to square one, just us floating in a universe that doesn't seem to care whether we're here or not. Now, flip the script. What if 3IATLAS does something we can't explain? Maybe it shifts course in a way that's impossible to brush off as random. Maybe pieces break off in a way that looks intentional. Or maybe, against all odds, we pick up an actual signal. The scientific world would go into overdrive. Every telescope would lock on. Researchers would argue, test, and retest explanations. The debates would spill out of journals into headlines and dinner table conversations. But it wouldn't stop with science. Governments would have to step in. The UN has rules for this sort of thing, protocols for first contact, though nobody's ever actually used them. Do they even apply to a silent probe, or to something artificial that isn't talking back? Nobody really knows because, honestly, we've never had to deal with this before. Then there's the public. Picture the reaction if we confirm that something artificial from another star system is poking around our solar system. Some people would be thrilled, convinced it proves we're not alone and that intelligent life is out there. Others would be scared stiff, worried about threats or invasions. And a whole crowd would just be skeptical, demanding more proof, poking holes in every claim. insisting there's got to be a natural explanation we missed. The range of reactions would be all over the place, and honestly, managing that chaos would be a nightmare for scientists, officials, and the media. We all know how fast rumors and bad information spread these days. An event like this, it would test just how well we can handle a real paradigm shift. Or maybe we're just reading too much into things. Maybe 3IATLAS really is just an oddball comet with strange chemistry and a lucky path. Maybe what looks like a course correction is just gas venting off at the perfect angle, purely by chance. Maybe our measurements are off, or gravity is playing tricks, or sometimes the universe just coughs up coincidences that seem meaningful but aren't. Humans are great at spotting patterns, even when there aren't any. We see faces in clouds, hear messages in static, find intention where there's only chaos. That instinct kept us alive back in the day, but it's not always helpful when we're trying to figure out the universe. That's where science comes in. We test our ideas, we check the data, we stick with the simplest answer that fits the facts. Right now, the comet theory still holds up best. It asks for the fewest leaps of faith. It uses physics we already know. It doesn't need us to believe in alien tech or civilizations we've never seen. Sure, the anomalies are real. Weird things happen in nature. The trajectory is precise, but sometimes the universe is just weird, until we find evidence that absolutely can't be explained any other way. Sticking with the natural explanation isn't just safe, it's good science. Good science means staying open, even when the possibilities make us squirm. Sometimes our models just don't fit and the data keeps nudging us someplace we didn't expect. That's when you need to admit you don't have the answer yet and keep digging anyway. That's exactly where we are with 3IATLAS. We just don't know. The comet idea has its flaws. The artificial theory doesn't have real evidence. So we're in this weird in-between, somewhere between not knowing and maybe knowing, where everyone's speculating and certainty is nowhere to be found. The only way forward, more watching, better data, and the humility to admit the universe might be stranger than we can even imagine. Here, what we do know. When 3IATLAS swings past Jupiter's Hill radius in 2026, it'll be a turning point. If it cruises through without anything weird happening, if it acts just like a comet should, then the conventional story gets a big boost. Not proof, of course, because you can't actually prove a negative, but enough to make wild theories look like overkill. But if the object pulls off something unexpected, something that hints at a controlled path or deliberate maneuvering, then everything changes. The bar for calling something artificial is high, and it should be, but it's not impossible to reach. Imagine it makes a second, perfectly timed course correction, or splits into pieces that move in sync, or it gives off heat that a regular comet can't explain. Or, wild as it sounds, we pick up a radio signal. Any one of those could tip the scales fast. So for now, all we can do is wait and watch. Gather more data, tweak our models, and brace ourselves for whatever comes next. Because no matter what 3IATLAS turns out to be, a regular comet or something more, it's already changed the way we think about interstellar visitors. It's shown us these objects can surprise us, that our models have limits, and the line between natural and artificial isn't always clear. It's forced us to ask questions we never really thought about, to set up plans for wild scenarios we barely believed possible, and to face the idea that our cosmic neighborhood could be busier and weirder than we ever guessed. And this goes way beyond just this one object. Every interstellar visitor from now on will get more attention. We'll build better detectors. We'll sharpen our analysis. We won't just look for comets and rocks. We'll also be watching for anything that seems built, anything that acts like it has a purpose. The whole idea of what counts as evidence will get argued over and pinned down. Science will have to come up with standards for claims of artificial origin. And outside the labs, people will have to deal with the idea that maybe we're not the first smart species in the galaxy, that others could have come before us, or might even be watching now. Whether that idea thrills you or scares you probably depends on your mood. Some folks would see alien tech in our solar system as a dream come true. Finally, proof we're not alone. proof that thinking and exploring isn't unique to us. For others, it's more like a nightmare, a reminder of how small and exposed we are in a universe we barely understand. For most people, honestly, it's probably both. Wonder and fear, hope and worry, curiosity and caution, all mixed together. Let's not get too far ahead of ourselves. Right now, 3IATLAS is a comet, an interstellar visitor with some odd quirks, sure, but nothing that screams alien probe. The precise path is unusual, but not impossible. The timing of its boost is interesting, but not proof of anything. Its approach to Jupiter's Hill radius is eye-catching, but maybe just a coincidence. Every weird thing about it still has at least one natural explanation, even if those explanations are a bit of a stretch. And that's where we stand, stuck in uncertainty, with data pointing in all directions and no clear answer yet. 3IATLAS has thrown us a curveball. We thought we had comets all figured out, how they move, what outgassing does, the whole orbit thing. But as soon as you bring in an interstellar object with weird chemistry and a trajectory that's almost too perfect, our models start to fall apart. So maybe the models need a tune-up, or maybe we're missing something big about how interstellar objects get shaped by their time drifting through the galaxy. Or let's just say it, maybe not every object wandering in from the stars is something nature cooked up. Science is supposed to be skeptical. That's good. You don't just jump to wild conclusions. But science is also about following the evidence wherever it leads, even if that means heading straight into unknown territory. Now, as 3IATLAS moves outward and closes in on Jupiter's Hill radius, we get one last shot at figuring out what it really is. If it slides through the Hill sphere and nothing weird happens, if its path keeps matching the textbook version of a comet, that's a win for the comet theory. But if it starts pulling off unexpected maneuvers, changing speed or direction in ways gravity and outgassing can't explain, the mystery only gets deeper. And if it does something wild, deploys parts, beams out signals, acts in a way that just doesn't fit with anything natural, that's when everything changes. All eyes are on it. We're tracking, we're measuring, we're waiting. And after the encounter, no matter what happens, we learn something. If 3IATLAS turns out to be just another comet, we'll have a goldmine of new data about interstellar visitors. That'll help us understand how planets and comets form, how things move around the galaxy, and how to get ready for the next interstellar object. We're probably going to see more of them soon. The numbers are going up. But if 3IATLAS isn't just a regular comet, if we find real signs that it's artificial or moving on purpose, then we're in new territory. Now we're not just asking if alien life exists. We're asking, what do we do if it's already here? How do we react? How do we protect ourselves? Can we even talk to them? And honestly, how do we live with the idea that someone or something is out there watching us, maybe even taking notes? The real question, the one that keeps coming back, is whether we're ready for what the evidence might be telling us. We've always pictured the space between stars as empty, just rocks drifting through nothing. But what if that's wrong? What if the galaxy is full of travelers, probes, ships, things sent out by other civilizations, quietly moving from star to star on missions we can't imagine? What if we've been mistaking alien tech for natural stuff all along? Maybe 3IATLAS is just a comet. Or maybe it's just the first one we noticed among many that have already passed by. The trajectory is too sharp. The timing is too good. The precision is almost unsettling. After that solar conjunction, something nudged it toward Jupiter with a kind of accuracy nature usually doesn't have. Maybe we'll find a perfectly normal explanation. Maybe new data will make all the weirdness click into place, and we'll laugh about how we almost let our imaginations run wild. But maybe not. Maybe we're watching something intentional, something that's been crossing the void for ages and just tweaked its path while we weren't looking. If that's true, if 3IATLAS is under someone's control, then the question isn't whether we're alone. It's whether they've been watching us for a while, and what it means that they're making their move now. Right now, 3IATLAS is out there, racing through space, closing in on Jupiter's Hill radius. Every day it gets a little closer. Every day the unknown shrinks and the tension ramps up. We're basically watching a cosmic thriller unfold in real time. This story started ages ago, millions, maybe billions of years back, in some distant star system we'll never lay eyes on. Now it's all coming down to this moment. An object that journeyed across the empty stretch between stars, finally meeting Jupiter in the next year and a half or so. And honestly, nobody knows how it'll end. Maybe it's just a comet playing by the rules, or maybe we're in for something no one saw coming. That edge-of-your-seat feeling, hanging between what we expect and what's actually possible, is what makes this whole thing so gripping. The facts, they're weird. The data doesn't add up neatly. The timing feels off. The path is almost too perfect. The clock's running, and soon we'll find out if this answers some of humanity's oldest questions or just throws new mysteries at us. Either way, we'll be watching, glued to the screen when it happens. And whatever 3IATLAS does or doesn't do when it finally brushes up against Jupiter, it's going to shift how we see ourselves and this universe. It's going to make us rethink what's really out there in the dark between the stars. Still, no matter how we feel about it, the truth stays the same. 3IATLAS is out there right now, flying straight toward Jupiter. Every day it moves closer. Every observation gives us a bit more to chew on. Every bit of analysis adds to the picture. And when it finally hits the hill radius, when we see its true colors, we'll get our answer. Maybe it's not the answer we hoped for or the one we guessed, but it'll be something real. And once we have it, new questions will pop up. That's how science works. The universe never hands over all its secrets in one go. It makes us chase them down bit by bit, with new mysteries always waiting. Honestly, sometimes the questions matter more than the answers. Sometimes just asking changes us. 3IATLAS, whatever it turns out to be, has already done that. It's made us curious. It's made us look up and wonder. It's reminded us that the universe still hides things in plain sight. And maybe, just maybe, it's bigger and stranger than we ever dared to dream.